All right. So today we're going to be talking about modeling integer addition with chips/tiles. That's what we did in our last lesson, but we're also going to compare it as we do the number lines right next to it. So for this set of exercises, it's a lot like what we did last time. We're going to start by circling the operation, which right now might seem like a very unnecessary step because every time we're just adding. But if we build this habit now, then when we start introducing subtraction, it'll be easier to catch when we're subtracting versus when we're adding. So circle the operation. There it is. We're going to be adding in this problem. Maybe I'll even leave myself a little note that we are adding. Then it says model each integer addition exercise with chips tiles on the left and a number line on the right. Let's do that. We have done this before. It says 8. That's a positive number, so I'm going to represent 8 with positive counters. Let's go ahead and draw those. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I am adding, combining it with 9. That's another positive number, so I'm going to draw 9 more. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That was just like what we did last time. So nice and easy. When we add them all up together, we can count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 8 plus 9 is equal to positive 17. Because we had 17 total positive counters or chips or tiles or balloons or whatever you want to call your model. What does this look like on a number line? Now, nobody draw anything just yet. I want you to just to watch. Okay? What we're going to draw is show how we are starting at 0, just like our basket starts at 0. And when I start at 0, I'm going to go from 0 to 8, because that's what that first number says. So I'm going to draw a line or an arrow that goes from 0 to 8. 5, 6, 7, 8. It's kind of like where the basket takes us with the first 8 balloons. And then this is why I do this just a little bit different, because I have technology, and that's why I want you guys to be watching instead of drawing. Okay, so what I do here is I'm going to show how much of an impact 9 has. So I like to draw that arrow from 0 to 9, but I have technology, so after I draw it, I can pick it up and move it. You guys can't do that, right? But when I do it this way, I can see just how far it takes me. Instead, what you guys will have to do is, instead of figuring out what 9 is, when you draw your arrow, you're going to have to go like this. Starting here, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. I drew it 9 long, and where did it take me to? Where did I end up? 15, 16, 17. So 8 plus 9, showing on that number line diagram, is equal to 17. Just like it was with the chips and tiles, this is just another way of showing our work. Okay? Any questions so far? Do you think you can model number 2 with chips and tiles? Okay, after you model with chips and tiles, then together we're going to model it on the number line. So with your groups, model 7 plus a negative 2 with your chips and tiles, and then we'll do the number line together. Pausing the recording so you can do this on your own. Okay, let's go over it. Now we have 7 plus, we're circling the operation, don't forget to do that, and maybe make a note to yourself that we are adding. It's always good to acknowledge that because pretty soon we're going to add in some subtraction and we need to make sure we're paying attention to it. And this is a positive number, so 7, I'm going to represent that with positive tiles. 2, 3, 4, 5, 6, and 7. And we're combining it with, this is a negative 2. So I need to represent that with negative tiles. Did you catch that? Okay, good. And did you also remember to mark them differently on your paper? Like I did, these positives were yellow and empty. Negatives were red and shaded in. And then when I do that, I'm like, hey, wait a second, I have some 0 pairs. And then I count up what's left after those 0 pairs. 1, 2, 3, 4, 5. And they're positive tiles, so that's positive 5. This is what it's going to look like as we do it with our number line. We're going to start at 0, and as I draw to 7, make sure I count up. So 0, 1, 2, 3, 4, 5, 6, 7. Now, when I drew my negative tiles, I drew them a different way. How do you think I'm going to draw negative on the number line? Willow? We're going to go backwards, exactly. So, the way you guys are going to do it, starting right where we left off, which was right here at 7, I'm going to go backwards in the other direction. I'm going to count 1, 2 in the negative direction. And where did I end up? At 5. So, yeah, it is easy, right? We're just modeling the same type of thing in a different way. The positive this time, we're going to go to the right, and the negative, we're going to go to the left. Let's maybe make note of that. When we're doing it on the number line, our positives are going to go to the right. I'm writing that down so I don't forget. Positives go to the right, and the negatives are going to go to the left. Nice and easy, right? All right, do you think you can do number 3 on your own? Okay, I want you guys to try number 3, 4, and if you have extra time, number 5 with your groups. Ready, set, go. All right, let's see how you guys did. I'm going to continue to circle the operation. This is addition, so just going to leave myself a note that this is addition. What is it that I'm going to be adding? Let's see, this is negative 5, so that's going to be 5 negative tiles. To that, I'm going to be adding, this is 6. It must be a positive 6 since there's not a negative sign in front. So 1, 2, 3, 4, 5, and 6. And look at that. Do you see all these 0 pairs? Yep. So what's left over after I have all of those 0 pairs? What is it that I have left? Cameron? 1, and it's a positive tile, so that means it's going to be equal to a positive 1. How are we going to do this over here on the number line? I'm going to start here at 0, and I'm going to go back negative 5. So 1, 2, 3, 4, 5 to the left. I went backwards to show that it's negative. And now I'm going to pick up right where I left off, but this time I'm going to go to the right because that's a positive number. So going to the right, right where I left off. 1, 2, 3, 4, 5, and 6. Where did I end up? Right here at 1. So negative 5 plus 6 is equal to 1. Let's take a look at number 4. I'm going to start being lazy now. I'm still going to circle the operation so that I can acknowledge, yes, we are adding. Leave myself a little note that we are adding. But I'm going to be lazy in how I draw. I'm not going to keep on doing those filled in solid negative tiles. Now I'm just going to go like that. How many of those should I draw? Braxton. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And to that, I should be adding 4 positives. So right below that, 1, 2, 3, 4. How many 0 pairs did I just create? How many 0 pairs do you see? Thank you, Kate. 4. Those are all those 0 pairs. After I look at those 0 pairs, what is it that I have left over? 1, 2, 3, 4, 5. So it's equal to 5? No, it shouldn't be equal to 5, Zoe. Negative 5. So yes, there are 5 things left over, but what are they? They're negative. So we can't say that it's equal to 5. We have to say it's equal to negative 5. So make sure we're careful on that. Now let's take a look at the number line. We're going all the way back to negative 9. So going towards the left, the negative side, 1, 2, 3, 4, 5, 6, 7, 8, 9. And picking up right where I left off, this is a positive 4, so I'm going to go in the positive direction. 1, 2, 3, 4. And where am I leaving off? At negative 5, exactly. So that number line will also help us to confirm that, yes, I have 5 things, but they're negative thing, so -5, because we ended up here at -5. And the last one. Hey, look at that. I'm still adding. Make sure you circle the operation. I like to write that note that we are adding. What is it that I'm adding together? -6. So I'm going to represent that. I'm going to do something different now. Let's do rocks. 1, 2, 3, 4, 5, 6 rocks. And to that, I'm going to be adding -8 is 8 more rocks. 1, 2, 3, 4, 5, 6, 7, 8. What do I have then? We can count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 whats? Negatives, exactly. 14 rocks. So I'm going to say -14. Now, let's take a look at what that's going to look like on that number line. -6. So I'm going to go in the negative direction from 0. 1, 2, 3, 4, 5, 6. Picking up right where I left off, I'm going to go -8. So look at what's happening. I'm going in the negative direction still. 1, 2, 3, 4, 5, 6, 7, 8. Where did we end up? At -14. Nicely done. Yes, Weston. Probably just because you weren't super careful on how you were counting. So that's just the best way to fix that, is just make sure that we're super careful when we're counting. But the thing is, all of your left-hand column should match all of your right-hand column. We should have 14 rocks, so -14, and we should have used our number line to get all the way down to -14. So now it's time to discuss. First question, how are these models related? Do you see any way that they're related? Where do we see the 0 pairs? Can we see 0 pairs in each model? And then discuss with your group which model do you prefer and why. So discussing with our groups first. Answer those questions with your groups, and then we're going to come back for a class discussion. I'm going to pause the recording as students discuss in class. Okay, how are these models related? Especially when we look at something like 3 or 4, how does this side relate to this side? What do you see, Caleb? Yeah, in both model, we are able to figure out the answer. Yes. What else? Cody? They both show numbers. Yes. Blake? Well, so we're not really comparing each of the problems so much as we are comparing the left side with the right side. So are the models related? Like if we're using counters, is that related to when I'm using the number line? Braxton, R. Yep. Here's some other ways that haven't been mentioned. Are we representing positives and negatives in exactly the same way? How am I representing positives over here? On the chip tile, how am I representing positives? Maybe I'm using a plus sign, right? Or maybe I'm using a positive counter like that. Am I representing the negatives in the exact same way? No. How am I representing the negatives? Either a negative sign or a filled in tile. So do we have to have similar but different ways of representing positives and negatives? Yeah. How am I representing positives over here? How do I represent positives? Troy? Exactly, we go towards the right. And how do I represent negatives on the number line? Weston? We go to the left. Are they similar? Yeah. But are they different? Yeah, so that's something that they have in common. Even though we represent positives and negatives differently, we represent positives and negatives differently in each type of model. I want to focus on the 0 pairs. Can you see 0 pairs here? Yeah, you can. You can see them because in a way it's kind of like they overlap. So we can see the 0 pairs in the overlap. Can you see 0 pairs here? Do you see some overlap? How much do they overlap? 1, 2, 3, 4. Just like how many 0 pairs? 1, 2, 3, 4. So can we still see 0 pairs? Yeah, we can. It's kind of noticed in the overlap. So in this model, we might have positives counteracting the negatives in a zero pair. In this model, we might have positive arrows overlapped and counteracting negative arrows. So we can still see the zero pairs. And I'm curious, which model do you prefer? I just want to take a vote. Who prefers the chips and tiles? Raise your hand. Okay. Who prefers the number lines? Raise your hand. Okay, so did you see how there were students raising their hand for each model? That's why I don't teach just one. That's why we talk about both. Because not everybody's mind works the same way. And sometimes, maybe you started off liking this one until you saw the number line. You're like, wow, I really like that one a lot better. Or maybe after seeing the number line, you're like, nope, I hate that. I'm going to stick with the chips and tiles because that's what I like better. Okay, and now it's practice time. All right. For the rest of this lesson, it's really just practice. So let me explain what I want to see happen for the next little bit. On this set of problems here, it says circle the operation. Hey, that's not a new direction, is it? We're still going to go through and circle the operation. Which again, right now you don't understand the value of it, but we're building habits. I want to get in the habit of always circling the operation. And then if we continue to read, it says use a model. Can you use chips and tiles? Yes. Can you use number lines? Yes. Do you have to use both? No. You get to pick which one you want to do. So back here we discussed which one is your favorite. And if you raise your hand saying my favorite one is the chips and tiles, then you can continue to use the chips tiles model. If you raised your hand saying I prefer the number line, then you're probably going to continue to use the number line model. Okay? You can use whichever model you prefer. When you get over here to the right-hand side, notice what it says. It still says, circle the operation. Does it say we have to use a model now? No, it doesn't. So you can do this any way you want. If you feel like I'm ready to do this in my head, great, do it in your head. But if you keep on making a lot of mistakes, it's probably a good idea to draw a model. You are always able to draw a model, whether it's a number line or a chip tile. I want you to draw a model. But let's talk about what this part says right here. Do you see how it now says, justify your answer? You have to be able to explain it in some way, shape, or form. All right? So let's kind of compare the two different ways and what that's going to look like. Let's go to number 8. Let's all do this one together. This says 5 plus a negative 4. So 5. I'm probably going to draw 5 positive tiles. To that, I'm going to add, this says negative 4, so I'm going to add 4 negative tiles. I'm going to count up my 0 pairs. See, oh, look at all of those are zeros. I have 1 extra tile left over, and that extra tile is a positive tile. So 5 plus a negative 4 is equal to 1. If I wanted to do this with the number line, the challenge is I would first have to draw that number line. 0, 1, 2, 3, 4, 5. So I have to first draw the number line where I can go 1, 2, 3, 4, 5 in the positive direction, and then 1, 2, 3, 4 back in the negative direction, and we can see how we landed right there at 1, just like we should have. So that's how I would do it using whichever model I prefer. I would do it that way. But let's look at number 16, because we don't have to use a model anymore. Should we still maybe? Yeah. Do we have to? No. The answer to this, you know what? I'm going to pause the recording. I want you guys to see if you can figure it out on your own. All right, and what is 12 plus a negative 9? Remy. It is 3. How did you get that? Okay, so you drew the tiles. Great. Who did it without having to draw the tiles or the number line? Good. I want to hear your justification, because are you still allowed to draw tiles here? Absolutely. And if you draw tiles, guess what? That is your justification. But if you don't want to draw the tiles, how are we going to justify it? Cody. Okay. Okay. That would work. It's kind of hard to justify. So let me add just a little explanation here because it's not wrong. But if we visualize this, we're counting up 12 and then we're going to count back 9. Think about what this would mean. We end up with 9 0 pairs, right? Because aren't these 9 rocks going to counteract 9 of those balloons? And then what do I have after we got rid of those 9 balloons? We have 3 extra balloons. That is one way that you can justify the answer. Okay, so if you're not going to draw a model, I want some sort of an explanation. What are your thoughts, Blake? You had your hand raised? Okay, go ahead. Yes, I think that's a great way. And so instead of drawing out a whole model, you kind of sort of draw out a number line, only without the line. You drew 1 through 12, and then you crossed out 12, 11, 10, 9, and so on, and then you had 3 left. That's a great way to do it. And Braxton, R. Okay, that's a good connection. We're not going to talk about that connection yet, not until we get to subtraction, but I'm glad that you're already seeing that connection in advance. Nicely done. Okay, going to pause the recording while students work on these problems. Focus on the left-hand side first, modeling in any way that you can, and then when you finish that, then you can model, or not model if you choose not to model, but justify on the right-hand side. Pausing the recording while students work in class. Ready, set, go. Continue to work on these. Only continue the recording, only continue the video when you're ready to check your answers, because the answers are going to be up on the screen when you continue past this. Pause the video now. All right, here are the answers. Please check them. Again, I'm not drawing models for each one of these. This is just you checking your answers against what I have. Just like I'm not writing justifications, you are just checking your answers. And now that you've had a chance to check your answers, your homework is on the back side, and your homework is more of the same, just more chance for you to practice at home. If you want to get good at this, that includes practicing on your own time, not just in class time. So, your homework, chip tile model and number line, chip tile model and number line, chip tile model and number line, and then the last set is just more like what we did, right? Choose any model that you want and justify. That's it for the video. Thanks for watching.